We're going to talk about parabolas today. Stick with me on this first one. And then what we're going to do from there is we are going to take a look at a couple examples. I want you to do those examples on your own and pause the video and then come back and check your answers. Okay, so for this first part that we've got, when we talk about parabolas, we've got two forms of the equation. They call it standard form, and it looks more like transformational form to me, but we're not going to split hairs on that. So we have x minus h squared equals 4p. Sometimes they'll use a instead of p, so just be aware of that. Okay, so this is for things that are up or down. So you look to see which one of these is squared, and because my x is the one that's squared, it's either going to be facing up or it's going to be facing down. Remember that it's positive, that's a smiley face. If it's negative, that's going to be a frowny face. On the other side, our standard form will be y minus k squared equals 4p. Again, you might see 4a, x minus h. And because it's my y that's squared, that's going to either face the right or face the left. If it faces the right, that's positive. If it faces the left, that's negative. So just think about it as the ends of a battery. Okay. So let's look at some labels of some things. And there is a link in the comments or description about where I actually got this flip book. It's fantastic. Let's look at this one. Is called the focus. This line is called the directrix. This, of course, is my vertex. And just to kind of keep you posted of what all these things mean, this value from your vertex to your focus is the value of P. And this is also the value of P. And what's interesting is if I take this out to the leg, right, that's going to actually be 2P. But what's interesting is when I carry that down, that also equals 2P. Your distance from one leg through the focus to another is actually called your latus rectum. Sorry, guys, I didn't name it, right? And so that latus rectum is the equivalent of 4P. So this that you see in the equation, this 4P, that's actually talking about this distance going through your focus from one leg to another. Okay? Your directrix is always behind your vertex, and your focus is always in front or where the legs curl around. Same thing here. You have the same notations. You're just going to flip it sideways is all you're going to do. The only other thing that we didn't talk about, which I can actually label on this one, would be our axis of symmetry. Okay, so it's asking on these examples for your axis of symmetry. So that's where you're going to find it. It's always the line that passes through focus and vertex. Okay, so look at the two numbers that are in common of those, and that's going to be your axis. So as far as terms that you need to remember, again, we're looking at parabola. We want to make sure we know our vertex. That's going to be HK. Our focus, okay, that's going to be plus or minus P from wherever it is that you have. You need to know your directrix. You need to know your latus rectum. And you need to know your axis of symmetry. All right, let's go ahead and look at an example problem. So in this one, right, it looks like it is the y that's getting squared. So if it's the y that's getting squared, I know it's either going to face left or right. If it's x, it would be up or down. So I'm going to immediately look to this. That is my 4p, right? So when I have that equation here, this value right here is my 4p. Now that 4p, the sign on that tells me whether or not it's facing left or right. Remember I said if it's facing to the right, that's positive. If it's facing to the left, it's negative. And I have nothing against left-handed people. I've got a son who's left-handed, and he will tell you that it was not a happy thing when he was trying to find things dealing with lefties. Okay? So maybe that's a way to remember it. All right, so let's look at our x value and our y value to find our vertex. So our vertex here is going to be 5, -2. 5, -2. And I get that from my shifts here, right? That's 5, that's -2. And then I'm going to go ahead and set that 8 equal to 4 times my p. So divide by 4, and p is equal to 2. So what do I do with that? Well, let's go ahead and map out our vertex. Our vertex is 5, -2. So 1, 2, 3, 4, 5, -2. So there's my vertex right there. I'm making it extra big. Because my p is 2, and I know we said that this is a y squared and it's positive, so it's going to be facing that direction. That means if my vertex is there, that my focus is going to be to the right of it, and my directrix is going to be behind it, and then my axis of symmetry is going to go through it. So let's take a look at those things. Okay, so if I have 2 forward, that would be my focus. And then 2 backwards would be my directrix. So that would be this line right here. So I'm going to go ahead and make it in red. And maybe I'll put some lines through it so that we can see. Okay, that's my directrix right there. Okay, and then of course my line of symmetry, I'll do that, let's do that in green. My line of symmetry is going to go through the vertex and my focus. So that's my line of symmetry. So let's go ahead and, or axis of symmetry, excuse me, not your line of symmetry. Let's go ahead and look at what this is. So this green is actually y equals -2. The red here, that's x equals 3. And then my vertex, I said, was 5, -2. And then 2 greater than that for my focus is going to be 7, -2. So my axis of symmetry is y equals -2. And my directrix is x equals 3. So now I have everything that I need except how do I draw this puppy, right? Remember when I talked about 2p being the distance between your focus and the legs? So my p over here, remember, was 2. So 2p is going to equal 4. So let's go ahead and plant from my focus. 1, 2, 3, 4. 1, 2, 3, 4. And what that does is that gives me a line through my focus. That is my latus rectum. It's the 8, the value of 8. But by splitting it up 2 and 2, or 2p and 2p, it allows me to go ahead and draw my my legs of my parabola. So let's go ahead and draw that way and then draw this way. Okay? So there is our first parabola based on this equation. That's pretty cool, huh? All right. Let's go ahead and take a look at the next one. I really, really want you guys to go ahead and pause this and then join me again so that you can check your answer to see what you've got. All right, let's take a look at number 9. This one, we have x being squared, so we know it's going to be up or it's going to be down. And I look at my latus rectum to see if it is positive or negative. This is negative, so we have a frowny face. So we know that we're going to have a graph that goes down. And I'm actually going to draw that like this just so that I remember. My vertex is going to be based on these numbers. So that would be -3 and -4. -3 and -4. All right. And then what I want to do is I want to take that -16 and have it equal 4p. Divide both sides by 4, and I end up with -4 equals p. Now, do you remember where I use that p? It's to find your directrix and to find your focus. So let's go over and let's map out where my vertex is. So my vertex is -3, -4. So that's this dot right here. I said initially that this thing was going to be facing downwards. That means I need to go down for my focus. I need to go up for my directrix, okay? And the amount that I go is this right here. So let's go ahead and make a blue dot for my focus. So I'm going to go down 1, 2, 3, 4. So there's my focus. And then I'm going to go up 4, and that will give me my directrix right there. And I can go ahead and mark this as, right, we'll go ahead and make it as much as we can like a dotted line. Not quite, but not bad. And we want to go ahead and label what that value is. And we know that that value is equal to y equals 0, right? Because if we move that up and down on the axis, my focus, that value is going to be -3 and 8, -8. Okay, so my focus is -3, -8. My directrix is at y equals 0. Ooh, my axis of symmetry. That axis of symmetry, remember, goes through my vertex and my focus. So that would be my line of symmetry. So that is equal to y, or x equals -3. X equals -3. Okay, so now we got to get going drawing this puppy. And remember that our p value was 4. So we want to go 2p on either side from my focus. So 1, 2, 3, 4, 5, 6, 7, 8. That's 2p. 1, 2, 3, 4, 5, 6, 7. Oops, we're off, but that's okay. We can still do it. All right, so that is how wide this particular parabola needs to be. So I'm going to go down this way, and there's probably a better way to make it look a little bit smoother, but that's about what we've got based on this equation and these numbers that we have here. All right. Okay, last one. Again, pause this. Go ahead and see if you can get it done on your own, and then come back and we'll go ahead and take a look at it together. All right, let's see. We got y squared. So this tells me that it's going to be to the left or the right. But what is all this junk here? Normally, I have my lattice rectum attached to the one that's not squared. So let's go ahead and see if I can rectify this. If I multiply both sides of this by -28, then this and this are going to cancel out. And so I have y squared equals -28 times x minus 1. That is much better. Okay, so now I can get my vertex. I don't have any shift on my y, so that's going to be 0. And my x is the value of 1. So 1, 0 is my vertex, right? Remember that we said on this previous one, right? My vertex is HK. That's where we're getting it. All right, let's look at our lattice rectum. So 4p is equal to -28. Divide both sides by 4. P is equal to -7. So with that negative, I know not only is it going to be left or right, but because it's negative, it's going to be the one on the left. So I'm going to go ahead and put it that way so that I know my focus is to the left, my directrix is to the right. All right, let's go ahead and map out my vertex. So 1, 0, there's my vertex right there. 7 is where my focus is going to be in front of that. So 1, 2, 3, 4, 5, 6, 7. Okay, so my focus is -6, 0. And then that axis of symmetry goes straight through those two, which is just my x-axis. So my axis of symmetry is y equals 0. And now we got to map out our directrix. So we go back 7. So 1, 2, 3, 4, 5, 6, 7. So we have the line right here. That's my directrix. And then to map out, so that is 1, 2, 3, 4, 5. That's 8. X equals 8. All right, so we got all the gang there. And now we need to go ahead and figure out how wide my parabola is. So remember that I do 2p from the focus to the arm of the parabola. Okay. All right, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm going to call it right there. Okay, and upwards, we're going to have that same problem. 11, 12, 13, 14. Okay, so this is a little bit awkward, but we'll do what we can. I'm turning my tablet here to see if I can go ahead and do my angles here. Oop, not quite. Hang on. We'll get there. All right. That's better. Okay. So that is kind of a crazy parabola because we have such a high latus rectum. And if we take a look at the value from each of those through that line, that would be that 4p. And remember that from here all the way back to your directrix, that's 2p. Okay. And then from here to here, that's just regular p. So that value of p is kind of the key to unlock everything that you've got here. Okay. All right. Go ahead and take a look at some example problems on parabolas. And I'm going to actually do another video with some example problems just in case you feel like you need additional support.